Hello, class. Welcome. Today we're going to talk about limits through algebra, how limits can be approached through algebra. But as our last lesson spoke about, we had limits graphically. So at this time, I'd like for you to pause the video and give you about 3 minutes or so to answer these limit statements, all 5 of them, and then this f of 1 as well. Pause the video now. All right, I'm going to go ahead and write answers, check them out. Answer to the first one up here on the left is 1. Oh, I'm in white. That's not a good thing. Please give me something else. 1, and this is 3, and this is 0 on the right. Limit as x approaches 1 is 2, and then the limit as x approaches 2 does not exist because the values on either side, the left limit and the right limit, are not the same. All right, so as I said, the objective for today is to define and find limits using a variety of methods. There's good old Albert. He is saying, once we accept our limits, we go beyond them. I hope that's true with you. All right, so we already did graphically. And you remember there were 3 other ones from the last lesson: direct substitution, dividing out, and rationalizing. That's what we get to do today. We'll figure out each of these. So direct substitution will be what we do first, and then we'll go into dividing out and then rationalizing. You guys hopefully are familiar with that a little bit. Okay, so for number 3, everybody take a look. It says find the limit as x approaches 2 for this. So we always need to check and see if we can just plug that value in. Right? That should be the first thing we think through, which is called direct substitution. So x approaches 2. If we plug into everywhere there is an x, it's going to look like that. And let's simplify that down. Let's go ahead and say 4 minus 12 plus 8 over negative 2. And that ends up giving us, it looks like 0 over negative 2, which equals 0. And that's really important to note. Everybody, if you're taking 0 things, and you divide it by any number, that equals 0. Please don't get it confused. All right? And just so that we're clear, what happens if you have 0 on the bottom and a number on top? That's undefined. Okay? So that would be like limit does not exist. So just make sure that you know the difference between 0 and something like this, like negative 2 over 0. That would be a does not exist situation. Okay, because that would be a vertical asymptote. Great. Let's go ahead and try this next one. If we plug in negative 3, actually pause the video, plug it in, and see what you get. 30 seconds, ready to go. All right, as you direct substitute, negative 3 squared plus 4 over negative 3 squared minus 1, limit as x approaches negative 3, that would be 9 plus 4 over 9 minus 1, which is going to be 13 over 8. Awesome. Way to go, guys. So direct substitution, pretty straightforward. This is actually the first thing that you should always look for. Please don't jump into any of those other guys until you check this. Okay. Direct substitution, a little note, again, 0 over a number, call it n, equals 0, but n over 0 does not exist. Cool. So that's important to know. All right. So now, this is talking about substitution might not work if f is not a rational function. So what we have here is we have a beautiful square root curve. I feel like we talked about this yesterday. But if you have a right-hand limit, I guess if you're looking at this graph and you say, okay, the right-handed limit is 1, right? Because as we're approaching this, we're approaching 1, okay? You can substitute in 0 into your function, and it works, and you get 1. The left-handed limit, however, does not work. So there are some times that you might use substitution, and you're actually getting a wrong answer. You do need to notice, is there a limit that exists on both sides of the value? So this it's kind of hard to see, but we're actually talking about f of x equaling the square root of x plus 1. And we would say, hey, what's the limit as x approaches 0 of f of x? And do we see what would happen? If you plugged in 0 here, you would get 1. But substitution kind of skips the idea that it's possible for you to have no limit on the left. So just be careful. And if this were the case, we also talked about this yesterday, you cannot, or the last lesson, you cannot have a limit if there's nothing on the left side of the value. Just a little note there. All right, let's do some direct substitution here. Let's plug in 0 here. So find the limit. Actually, I'm going to pause. Let's pause the video and have you try this on your own. Ready, go. All right, you should have done number 5 and number 6 on your own. For number 5, limit as x approaches 0. That's just the square root of 1 minus 2 over 3, which equals negative 1 over 3. Pretty great. For the second one, the limit as x approaches negative 4. That's the square root of 0, because those cancel, minus 2 over negative 5. And that equals 2/5. Oh, wait, hold on. For this one, it does not exist. And here's why. Do you remember how we talked about square root of 0 being a weird value? If we actually graph this, we would say that if you plugged in any negative number, we would not be able to get a value. So this number is actually mathematically correct. But we're approaching it we have to think about how we're approaching from the left and the right. And for this one, because we got 0 here, and here's really the rule. If you ever get 0 in the radical, because radicals don't go to the left of 0, we're not allowed to have negatives. So that is a red flag that we already write. We go ahead and write does not exist. Okay, so 2/5 is what you get substitution-wise, but not the answer because there is no value to the left of plugging in negative 4. If you plug in negative 5, you're not going to get a value for this because it's imaginary. Now for number 5, we were fine with that. That solved correct. And if you look at this, we're not getting square root of 1. We're getting square root of 1, not square root of 0. So just red flag, if you have square root of 0, that means that the graph will stop at 0. All right, let's do some more direct substitution. Go ahead and pause the video and try these two. Ready, go. All right, so for this type of thing, it's super weird, super ugly. This is actually a complex fraction, but if you plug in 3, let's see what happens. 1 over 6 minus 1 over 3 over 3 plus 5. What does that become? Oh, we can multiply top and bottom by the largest denominator. That's the easy way to get this into a nice little doable thing. So if we multiply by 6 to the first, we get 1 minus, and that's 2 over 8 times 6. So 8 times 6 is 48, which gives us negative 1 over 48. No real restrictions with this, so you should be fine. Let's try, unless you do your math wrong. For number 8, plugging in 6, limit as x approaches 6 is 1 over 7 minus 1 over 5. 7 minus 4. Oh, I plugged in 7 in the bottom. Marby. 6. Okay. So the common denominator on top is 35. If you multiply 35 on top and bottom, you end up getting that would be 5 minus 7 over 5 minus 4 is 2 times 35 is 70. So we're going to say that that equals negative 2 70ths or negative 1 35ths. All right, next slide. You'll join me in the next slide. So I'm going to pause this video. I'll see you in the next video.